Good day, ladies and gentlemen. You're welcome to another section of Apex Easy Learning. I am PSAM. You can send your questions under the comments sections of the video. Um, Today we'll be looking at physical chemistry. Physical chemistry. And the topics we'll be looking at under physical chemistry is types of reaction. Types of reaction. We have different types of reactions: combination reactions, decomposition reaction, displacement reactions, double decomposition, catalytic, reversible reactions, thermal dissociation, oxidations and reduction reaction. All these reactions are the important reactions that we must know in chemistry. First of all, we'll be looking at combination reaction. Combination reactions deals with combinations of two or more substances to form a single compound. Two substances form a single compound, meaning at the end of the reactions, we are expected to have only one single compound. As you can see from this example, we have zinc plus sulfur, which give us zinc sulfide, meaning zinc is an element, sulfur is also an element, combined together to give us a compound. And when you look at a molecule of iron 2 chloride, a compound, and chlorine molecule, which is a gas, an element, also combined with a compound to give us just a compound. And in this last one example here, we have a compound, magnesium oxide and carbon 4 oxide, combined together to give us magnesium carbonate. That is just a compound. So two substances combine together to form one compound. So you note that two substances combine together to form one compound. That is combination reaction. Another reaction is decomposition reaction. Decomposition reaction. This one is the opposite of the combination, because this one involves reactions in which one compound splits up to form two or more. So it splits to give two or more simpler substances. So in this case, one compound will split and form two or more simpler substances. Now, when you look at calcium carbonate, in this case, when it's heated, it's going to give us quicklime, calcium oxide, and carbon 4 oxide. And when you look at lead 2 nitrate, this one split into three different components: lead 2 oxide, nitrogen 4 oxide, and oxygen. When you look at it, so in decomposition, we have one compound split to give us two or more simpler substances. Another one is displacement reaction. In this one, it involves displacement or replacement of one element by another. That is, one element always displaces one another. The elements that always replace or displace one another, they are called radicals. Radicals. So they call them radicals. And the ability of radicals to displace one another depend on their position in electrochemical series. That is, when you look at electrochemical series, we have it from potassium, sodium, magnesium, and the rest, as you can see them here now. Then you look at it, the higher electropositive are up, while the lower electropositive are down. In the electronegative aspect of it, you look at it, the lower electronegative are up, the higher electronegative are down, meaning electronegativity increases down this table, while electropositivity increases up the table. Electropositivity increase up the table, decrease down the table, while electronegativity increase down the table, decrease up the table. So meaning the less electronegative are up, while the less electropositive are down. Also, the higher electropositive are up, while the lower electropositive are down. So the ability of radicals to displace one another depend on their position in electrochemical series, meaning the element, this is electropositive element, which is above in electrochemical series, always displace the one below, while the more electronegative anions displace the lesser ones. So you note that. So when you look at this example, look at it. Iron here and copper, they are both electropositive. Look at it, iron is here and is above copper. So it is expected that iron will displace copper. When you look at it, iron now displace copper, and here we are having iron 2 carbonate. Instead of us having copper 2 carbonate here we are now having iron 2 carbonate, while copper has been displaced. And when you look at it, the more electronegative non-metals will displace the lesser electronegative. Look at it. I told you that the higher electronegative are down. So when you look at bromine and chlorine, chlorine is more electronegative than bromine. So it is expected that chlorine will displace bromine. So when you look at this example, so look at sodium bromide and chlorine. Chlorine remove bromine here, and here we are having sodium chloride. So bromine has been displaced. Another reaction here is double decomposition. In double decomposition reactions, we have exchange of radicals. Exchange of radicals. You remember what radical is. Now, in this double decomposition is a very, very important reactions, because this is one of the methods we use in producing insoluble salt in the laboratory. Now, in these reactions, we have two soluble reactants combining together to give us a product in which one is soluble, while the other is either insoluble or volatile or even gas. Or sometimes you see it forming a precipitate. Like in these reactions, when KCl reacts with AgNO3, a precipitate of AgCl will be formed, which is an insoluble salt, which it will also give us potassium nitrate. Here you can see how the radicals is exchanged. Potassium go to nitrate, the silver go to chloride. Now, when you look at reactions between these two soluble substances, H2SO4 and sodium nitrate, this one gives us a volatile compound, HNO3, and it gives us another substance, that is sodium hydrogen tetrasulfate 6, which is soluble. So this is double decomposition reaction. Another reaction is catalytic reaction. Catalytic reaction. These reactions are reactions that involve a catalyst. The reactions that is always influenced by catalyst. And what are catalysts? Catalysts are substances which alter the rate of chemical reactions, but itself remain the same chemically or quantitatively at the end of reactions. Catalysts always alter the rate of reactions, meaning catalysts can either increase the rate of reactions or decrease the rate of reactions, depend on what types of catalyst it is. So, but at the end of the reactions, the catalysts remain unaltered, remain unchanged. Now we have a positive catalyst. A positive catalyst are the one that speed up the rate of reaction. The positive catalyst increase the rate of reactions. A very good example of that is manganese 4 oxide. When you look at these reactions, in decompositions of trioxochlorate 5 to give us oxygen and potassium chloride. This reaction is very slow, but it can be affected and increase the rate by adding a little of manganese 4 oxide, which speed up the rate of the reactions and make us to attain the reactions in limited time. Now another type is the negative catalyst. These are catalysts that slow down the rate of reaction. They reduce the rate of reaction. Example is tetrahydrophosphate 5 acid. This catalyst can reduce the decomposition of hydrogen peroxide. Now hydrogen peroxide here decompose to give us water and oxygen. This reaction is very fast. If you decompose it within seconds, the oxygen there will disappear and you have left only water. So for that reason, we use this reagent, tetrahydrophosphate 5, to slow down the reactions. We also have some other catalysts, enzymes. They are also catalysts. These are organic catalysts which control the rate of biochemical reactions in living organisms. Enzymes helps in digestion of food. It also helps in fermentations of fruit juice, in the manufacturing of alcohol. If you look at different digestive enzymes, we have enzyme thialin, which act on carbohydrates, which break it down into giant sugar molecule, maltose, lactose, and the rest. Then we also have enzyme renin, pepsins, and the rest, repsin, amylopsin, and the rest. All these works and cause digestions of food. They are also catalysts. Another thing that is not really a catalyst but also influence the actions of a catalyst is promoter or inhibitor. The promoter and inhibitor, they are not catalysts, but they influence the efficiency of the catalyst. Promoter are substances which improve the efficiency of a catalyst. For example, ion catalyst used in our process is activated by the additions of trace amount of aluminum oxide, which promotes the activities of ion. When you look at it, in that case, ion in that regard is a catalyst, but the aluminum oxide added to it during the Haber process is a promoter which promotes the efficiency of the ion. Then we also have inhibitor. Inhibitor here, they are called catalyst poison. They are called catalyst poison, meaning they inhibit a catalyst. They reduce the efficiency of a catalyst. So these ones are the types of reactions we'll be looking at today. In our next class, we'll look at the rest of the catalyst. You can send your questions to our page, comment on those page on Twitter handles, Facebook page, Instagram, and on our YouTube. Thanks for watching. Peace out. You're welcome again. Last class we stopped on the types of reactions and we stopped on catalytic reactions. Today we are continuing with reversible reaction. These reactions is the reactions that proceed both forward and backward. That is reversible reaction. Reactions that proceed both forward and backward. When you look at this, we use two arrows, front arrows and the backward arrows, to show the reactions, meaning A and B in these ones will react to give you C and D, and C and D will also react under a different condition to give you A and B. So that is reversible reactions. A very good example of that is the reactions of iron with steam. When a heated ion is it reacts with steam, red hot ion. is react with steam, it will give us iron 2 diiron 3 plus hydrogen gas. It will liberate hydrogen gas. Iron 2 diiron 3, then it will give us hydrogen gas. Then also the compositions of calcium hydrogen carbonate, which will give us calcium carbonate, water, and carbon 4 oxide. So this is a reversible reaction, meaning this calcium carbonate plus water plus carbon 4 oxide can recombine again to give us calcium hydrogen trioxocarbonate. So another reaction is thermal dissociation reaction. In thermal dissociation reactions, it involves splitting of one substance into two or more simpler substances. It's just like a decomposition reactions, but this one is different from decomposition reactions in the sense that in decomposition we have a straight reactions, but in thermal dissociation reactions it involves a reversible reactions. Don't forget that in decomposition reaction is also splitting of one to give us two or more substances, but in dissociation reactions the reaction here is reversible. When you look at the decompositions of ammonium chloride here to give us ammonia and hydrogen chloride, it's also a decomposition of one to give us two, but here is a reversible reaction. So this one is a dissociation reactions. And another example is dinitrogen 4 oxide. In dinitrogen 4 oxide, at 140 degrees Celsius, it's converted to nitrogen 4 oxide, 2 molecules of it. And when the nitrogen 4 oxide cool again, it will give us dinitrogen 4 oxide. So that is thermal dissociation reaction. Another reaction is oxidation and reduction reaction. We are going to define oxidation and reductions in 4 ways. First of all, we are going to define it in terms of oxygen. In terms of oxygen, oxidation is the addition of oxygen to a substance, while reduction is the removal of oxygen from a substance. If you look at the equation here, sulfur 4 oxide combine with carbon to give us carbon 4 oxide and sulfur here. When you look at it, sulfur 4 oxide, you look at it, carbon here is without oxygen, but oxygen has been added to carbon, and we said oxidation is the addition of oxygen. So in that case, oxidation has occurred between the carbon and carbon oxide, carbon 4 oxide. So this one here, this is oxidation reaction. Now SO2 here, sulfur 4 oxide, has turned to sulfur, meaning oxygen has been removed. Here sulfur is with oxygen, here sulfur is without oxygen. So, and we said that reduction is the what? Removal of oxygen from a substance. So, meaning oxygen has been removed. Now, in that case, when you look at it, this one here is carbon, is the one that accepts the oxygen. So the substance which accepts the oxygen, the substance which accepts the oxygen is the reducing agent. Now you look at it. Why the substance which gives out the oxygen is the oxidizing agent? The substance that gives out the oxygen is the oxidizing agent. So meaning sulfur 4 oxide is the oxidizing agent. Why carbon is here is the one that is the reducing agent. In that regard, meaning that when you see a question, the one that become oxidized or reduced are the one that is in the reactant side. So if you see your options and you see CO2S there, you know that this CO2 and sulfur can never be the answer. So it's between the sulfur 4 oxide and the carbon that you have the one that become reduced, There be one that become oxidized, and the one that is oxidizing agent, and the one that is reducing agent. So in that case, carbon here is the one that become oxidized, and it is the reducing agent. So meaning that the reducing agent always become oxidized, why the oxidizing agent is always become reduced. So you take note of that, understand that very well. The reducing agent always become oxidized, why oxidizing agent always become reduced. So note that very well. We are also going to define oxidation and reductions in terms of hydrogen. In this case, oxidation is the removal of hydrogen from a substance, which is opposite to that one, while reduction is the addition of hydrogen to a substance. Oxidation is the removal of hydrogen from a substance, and reduction is the addition of hydrogen to a substance. Now, when you look at the reactions between hydrogen sulfide and bromine to give us hydrogen bromide and sulfur, you discover that here sulfur is with hydrogen and here sulfur is without hydrogen. So in that case, hydrogen has been removed from sulfur. In that case, this is oxidation, as we said that oxidation is the removal of hydrogen from a substance. And when you look at bromine here, is without hydrogen. Here you can see hydrogen is added to it. And we said that reduction is the addition of bromine, meaning here is the opposite of that of the oxygen. Now when you look at it here, the substance which accepts the hydrogen here is the oxidizing agent, which contradicts the other one. Meaning here, bromine here which accepts hydrogen is the oxidizing agent. While H2S, which gives out the hydrogen, is the reducing agent. So we have hydrogen sulfide as the reducing agent, while bromine is the oxidizing agent. So you still see it, the oxidizing agent always become reduced. Look at it. Why reducing agent always become oxidized in every aspect. So please note that. Another definition is in terms of electron. In terms of electron. Now, oxidation is loss of electron, while reductions involve gain of electron. Meaning oxidations is loss of electron, reduction is the gain of electron. Now let's look at reactions between iron 2 chloride and chlorine. In reactions of iron 2 chloride and chlorine, you look at it, iron 2 chloride, if you split it, iron is having 2 is iron 2. If you look at iron 3, this one, if you split this one is iron 3. Chlorine here is chloride is Cl minus. Chlorine here is Cl minus. So the oxidation state of iron here is 2. The oxidation number of chlorine here is -1. But this chlorine that is here is neutral, is a molecule. So the oxidation state of this one is 0. But look at this iron here, it has attained 3+, while this chlorine remain -1. Now when you look at this iron 2 here and iron 3 here, you look at it, meaning iron has lost 2 here, here is losing 3, meaning there is another loss of 1 more electron. So from iron 2 to iron 3, there is a loss of electron, that is oxidation. So from iron 2 chloride to iron 3 chloride, there is oxidation. But when you look at it, chlorine here is, this chloride is -1, this chloride here is -1, so we are not looking at this one. But when you look at this chlorine is 0, while this chloride is -1. So from 0 to -1, meaning this chlorine has gained electron. And we said the oxidation involves the gain of electron. I mean, reduction is the gain of electron. So meaning here, there is reduction. Don't still forget, This one here, chlorine, is the one that is giving out the electron, is the one that is giving out the electron. So is the oxidizing agent. So the substance that is giving out the electron is the one that is the oxidizing agent. Why the one that loses electron, that gains the electron, the other one that gains the electron is the reducing agent. So when you look at it, the substance which gain electron is the oxidizing agent. The substance which loses electron is the reducing agent. So chlorine here, which gains the electron, is the oxidizing agent. While the iron 2 chloride, which loses electron, is the reducing agent. Don't forget, we said the oxidizing agent always become reduced. Reducing agent always become oxidized. Just note that. Another one is in terms of oxidation number. Oxidation involve increase in oxidation number, while reduction results in decrease in oxidation number. When you look at these same examples that we have there, you look at it, iron 2 here, the oxidation number is +2. Iron here is iron 3. So there is an increase in oxidation number. So oxidation involve the increase in oxidation number. So iron has increased. When you look at it, reduction involve decrease in oxidation number. From oxygen, from 0, this chlorine is 0 to -1. So there is a reduce in oxidation number. So oxidation is the increase in oxidation number, while reduction is a decrease in oxidation number. So this is the end of this type of reactions. If you have any questions to ask, please don't hesitate to ask us under the comments and on our page. I remain P. Sam. Thanks for watching.